Okay, so for number 1, it says show that the quadrilateral with the given vertices is a trapezoid. So by definition, a trapezoid has one pair of parallel sides. So that's what we're going to be looking for to prove it's a trapezoid. And then decide whether it's isosceles. So we're going to look at whether I didn't realize that wasn't one pair of parallel sides for the trapezoid. And then to decide whether it's isosceles, we want the legs to be equal in length. So, graphing the points here, W is at 1, 4. X is at 1, 8. Okay, so to prove it's a trapezoid, I need one set of parallel sides. So I need the slope of YZ to equal the slope of XW, which in this case, it's just like a vertical line. So yes, they have the same slope. It's actually an undefined slope, which is kind of weird, but it is what it is. And then to prove it's an isosceles trapezoid, I need the length of this to be the same as this. So I need the length of YX to equal the length of the W. There's different ways to determine that. You could use Pythagorean theorem to find the length of this. You could also use distance formula. The other thing that I might do is just notice like it's down 1 over 4, up 1 over 4. So these dimensions here would give me the same dimension if I put it into Pythagorean theorem. So yes, the length of this does match this, so therefore it's an isosceles trapezoid. Of course, I can make that a lot more complicated, but just showing you the concept. Sometimes on testing you might have to do more work than that, but that's the idea. Okay, moving on. Number 5, it says find the measure of each angle in the isosceles trapezoid. So for an isosceles trapezoid, these two sides are equal, then the base angles match here, these base angles match, and then also these are supplementary. So like if this is angle A and angle A plus angle B equals 180, and we can figure out angles using that as well. So for number 5, let's zoom in even more, it's so tiny. Okay, number 5, it shows one of the base angles is 118. It says it's isosceles trapezoid, so the base angles would match. This is 118 as well. And then to find this angle, just 180 minus 118 gives us 62. So this would be 62, and this would be 62. Number 6, same idea, the base angles match. So therefore, if this is 82, this is 82. And then to get this one, because our lines are parallel, this is a transversal, these two angles are supplementary. So 180 minus 82 is 98 degrees. So we got 98 here and 98 here because the base angles are the same measure. Okay, next. It says find the length of the mid segment of a trapezoid. The mid segment right here is the average of these two numbers. So we can just add them and divide by 2. We get 14. So this length is 14. Some of you might have been able to just look at that and know that the middle number between 18 and 10 is 14. That's fine if you can do that, but we have to be prepared if you can't. And then number 8, we have to find the average of these two numbers to find the length of the mid segment. So 76 plus 57 divided by 2. This comes out to 133 divided by 2 is 66.5. So that's the length of this segment. Okay. Then number 9, it gives you the length of the mid-segment. It wants you to find the length of AB right here. There's two ways you could do this. You could look at the difference between 7 and 10 right here. So to go from 7 to 10, it's like plus 3. And then you could subtract 3 to get this value. So 7 minus 3 would be 4. That's one way to do it. Or you could use the equation like we did up here. You could do just like 10 plus x over 2 equals 7. Then to solve for x, multiply both sides by 2. 10 plus x equals 14. Subtract 10, and you get x equals 4. Okay, number 10. Trying to find AB here. So this plus this divided by 2 equals that. So we'll write it out like that. 11.5 plus x divided by 2 is 18.7. Then to solve for x, multiply both sides by 2. Equals 37.4. Subtract 11.5 from both sides. X equals 25.9. You could also technically use the shortcut just like we did over here. If you notice, the difference between these two numbers is, I don't know, 18.7 minus 11.5. So that would be minus 7.2, and then you could add 7.2 to get this number. 18.7 plus 7.2 is 25.9. Okay, then over here, we're going to graph one of these. I'm going to choose number 12 just based on how it like fits on the graph. It says find the length of the mid-segment of the trapezoid. To make it fit the best on the graph, I'm going to draw the coordinate plane right here. And then I'm going to graph the trapezoid. So A is at 0, 3, B 2, 5. So there's my trapezoid. The mid segment would hit at the midpoint of this line, and then the midpoint of this line, and then I need to find the distance between those 2 points to find the length of the mid segment. So it's going to take a couple steps. I need to find the midpoint of AD. Leaving this out would be a bad move because this shows up on testing quite a lot. Midpoint of BC. So I have to find the midpoint of AD and the midpoint of BC, those coordinates. So midpoint, this is on the reference sheet, but it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. So from A to D right here, add the x's, divide by 2, add the y's, and it comes out to 1.5. Then the midpoint of BC, so add the x's, add the y's, four, 4.5. Okay, so these are the points where the mid segment hits, and it wants to know the length of that mid segment. So I'm going to find the distance between those 2 points. the distance formula, which is on the reference sheet, x2 minus x1 squared plus y2 minus y1 squared. Notice how I'm writing in pencil. Like, there's a lot of things that can go wrong here. See, x1, y1, x2, y2. And then I will plug this stuff in. And I get square root of 18. To simplify that, this is correct. This is correct. And this is correct. That would be the length of the mid segment. I guess another way you could do it, you could find the length of AB and DC and then find the average of those two lengths if you want. I don't know. Either way, it's kind of a long process where you have to use midpoint and distance formula in the process. Okay. Next. Are you ready for next? Okay. Next gets easy again. Find the measure of angle G, and we have a bunch of kites. So in a kite, these angles here are congruent. And then the other thing that would be helpful is to know that the angles of a quadrilateral add to 360. So quadrilateral angles equal 360 degrees. And we're going to need to know that for this. So for 15, E and G are the same measure. So we're going to take 360 degrees, subtract 100, subtract 40 to see what degree measures are left over that needs to be split for those angles. So this comes out to 220 degrees. And then that needs to be split evenly among those two angles. So 220 divided by 2 is 110 degrees. So this is 110 degrees, this is 110 degrees. 16 is that same process. This little square means this is 90. So we're going to do 360 minus 150 minus 90. 120 degrees is left over, and that needs to be split evenly here. So 120 divided by 2 is 60 degrees for each of these. And it wants to know angle G, so box. Okay, one more and then we're done. So number 17, these two angles are congruent. So this is 110, this is 110. Then to find G, we're just going to do 360 minus 60 minus 110 minus 110. And whatever's left over is 80. So it's 80 degrees here. And that's it all. Okay, so your to-do list is, wait, let me give you your to-do list. Here it is. Okay, leave out the family tree so I can give you points. I got somebody trying to steal a base back there. Turn in notes for chapter 7, homework 7-5 on Schoology, and Alex. And yeah, okay.